Okay, we want to sketch the curve of this polar equation. So first we're going to graph this in Cartesian or rectangular coordinate systems with the horizontal axis being theta and the vertical being r. Normally for cosine the period is 2 pi, but there's a 2 in front, so we divide it by 2. So we're going to make 4 tick marks, 1, 2, 3, and the fourth one's going to be the period, which is pi. So this is pi over 2, and this is pi over 4, and this one's 3 pi over 4. And then let's do one more period, 1, 2, 3. The fourth one here is 2 pi. So this one is 3 pi halves, and this one's 5 pi fourths, and 7 pi fourths. Then we need to go as high and low as 3 and negative 3. Alright, so let's go ahead now and put the graph on there. And cosine of 0 is 1 times the 3, so it starts here at 3. Then it's going to cross, min, cross, max, cross, min, cross, max. So here is our graph of this function. Now to put it onto a polar graph, so this will be 0, and this is pi over 2, pi, and 3 pi over 2. And we see that we start out at 0. We need to be out 1, 2, 3. We'll be going out 3 in each direction, so I'll go ahead and put those on the graph. 1, 2, 3. Alright, so when the angle is 0, the r is 3. And then as we trace out this graph, we see that by the time we get to pi fourths, we need to be at 0. So let's just draw our pi fourths, and I need to be decreasing until I get to 0, or the pole. Alright, so now as we do the next chunk of the graph, let's do this whole piece of the graph from here to here in red. So the first thing I'm going to do is I'm going to have a negative radius going down. The farthest down it goes is at pi halves. It's at negative 3. So as I'm moving from pi fourths to pi halves, I need to be doing negative angles. So I need to be down here in quadrant 4, swing down there, and then from pi halves, by the time we get to 3 pi fourths is over here, but we're doing negative angles, I need to be back to the pole. Alright, now if I look at this next piece, that is going to be the piece from, we start at the pole at 3 pi fourths. By the time we get to pi, we are at 3. So we're going to be swinging around here to 3, and then we see we go back to the pole and back to the pole. And then we've got another loop there, and this particular one we do negative again. At 3 pi halves we're at negative 3. So 3 pi halves, I need to count up the other way, negative 3, and we swing in this quadrant around and back to the pole. And then our last little piece of the graph is this piece when we are at 0 at the pole at 7 pi fourths, then we go back out to 2 pi, and so we're going to swing back here and complete our picture. A little bit lopsided, but you get the idea. Now the next piece of this, we are going to use this graph and do the next problem, which says to find the area enclosed by the curve. So I'm going to go back to the next slide and we'll put it on that one so we can look and see how we get that area that we need enclosed. So if I want the area enclosed by the curve, I know the area is going to be integral between a couple of angles, 1/2 our function of theta squared d theta. So we'll set the integral up and then we'll complete it on the next slide. So that's going to be 1/2. Now what I'm going to do is I'm just going to use that green piece that I did and then use symmetry. So we see this area right here. If I started at 0, as I traced it out and went over here to pi fourths, I have that piece of the area that I need. And if you look here on the graph, it went back to we started at 0 and we went to pi fourths to trace that out. So I'm going to go from 0 to pi fourths, that'll give me half of a leaf, and I need 4 leaves, so I'm going to times this by 8. Now I need that function of theta squared d theta. So I just pasted this on the next slide, and so now let's go ahead and work that integral. I can reduce the 1/2 and the 8 and leave a 4. I'm going to multiply this out, square it. It's going to be 9 cosine squared 2 theta d theta. So I'm going to bring the 9 out and multiply it with the 4. So that's going to make 36. And then I still got the integral from 0 to pi over 4. And I'm going to use the half angle formula so I can replace cosine squared 2 theta with something that doesn't have a squared on it. And the half angle would be 1 plus cosine. Since it's already 2 theta and I need double that, that's going to be 4 theta d theta. Now we can take that 1/2 and bring it out there with the 36. I'm going to do that to just make it a simpler integral to work. So 18 times integrate 1 and get theta, plus integrate cosine 4 theta and get sine 4 theta. But the chain rule would have generated a 4, so I need a 1/4. And that's going to be evaluated from 0 to pi over 4. Okay, so let's do the evaluation. We've got 18. We're going to put in pi over 4 plus 1/4 sine pi over 4 times the 4, so that's just going to be pi, and then minus 0, and sine of 0 is 0, so that's all going to be 0. This one's also 0 because the sine of pi is 0. So our final answer, 18 pi fourths, or reducing that, 9 halves or 9 pi halves, is our area enclosed by this 4-leaf rose.